Hey, my name is Jeff, and I am a weird guy. Today, I'm going to introduce you to using CAM in Fusion 360. Because showing you is better learning than telling you, I'm going to walk you through a basic project. We are going to make this Yoshi wall art. I said we because I put the SVG for this Yoshi down in the description below, and if you want to, you can download it, follow along, and you can make Yoshi too. There's a ton to go through, so let's just... With a blank screen here, we need to either import or create a design. I have an SVG of everyone's favorite dinosaur thing, Yoshi, so we're going to start by importing the SVG into Fusion. Let's click Create Sketch and choose the XZ plane. Normally, the easiest is the XY plane, but today we're going to put it on the XZ for educational purposes and to prove that it doesn't really matter. Click Insert, then Insert SVG. Browse to the file and click Open. It looks like Yoshi has been in Australia because he's come in upside down. That's an easy fix. Just change the Z angle to 180. This grid is 1-inch squares, so we can see that he's currently about 7.5 inches tall. I want this to hang on the wall, so let's change the scale plane XY to 2.0, so he'll be about 15 inches. I personally think he looks better facing the other way, so I'm going to click horizontal flip, but if it's going on your wall, it's your call. It looks right, so let's click OK. The only thing I don't like about this design is this inner face area. If we pocket that area, it will leave a very thin ridge across the back of his jawline, and it means his nostrils will be fragile protrusions instead of small pockets. To fix this, we can double-click on the inner nose vector and hit the delete key. Yoshi looks ready to go, so click Finish Sketch. Now, Fusion is 3D software at every level. You cannot just create a toolpath in Fusion from a sketch. You have to actually model the finished product that you want to make in 3D and then make file paths from that. Select the entire sketch and extrude it down 0.6 inches. This will be the thickness and outline of our finished project. To make the pockets, click Extrude and turn the sketch back on. Click in every area to select all the pockets. We're going to extrude them down 0.3 inches. Make sure it's set to cut and click OK. Let's turn the sketch back off. We're done with that. This is what our finished project is going to look like when it's done. As soon as we're done admiring Yoshi's handsome face, we're ready to switch from design over to manufacture. Fusion always defaults me to millimeters, so let's switch the units on the left tree menu to inches. Before we can jump into toolpaths, first we need to create a new setup. So click New Setup. This looks complicated, but don't panic. This is where you get to define which bodies need to be machined, which side is facing up towards the router to be machined, how big is the board that we're going to be working with, and where is the X, Y, and Z origin point. As long as we're using a normal 3-axis CNC, we can ignore the machine and just leave the operation on milling. Fusion assumes those as defaults, so I've never needed to touch those. The next section is the work coordinate system. Let's come back to that one in a minute. I'd like to start with the model's body. Wouldn't we all? Click on the box near the bottom that says Body. It highlights our project body, showing that it already chose the only available body to be machined. However, if you have a model with multiple bodies, you can X that selection and then choose one or more bodies to be machined. At the very bottom is Fixture, which is where you can define bodies that do not need to be machined, but that the toolpaths need to be aware of so they can avoid running into them. We won't be needing those today. Okay, let's go back up to the work coordinate system in the middle. it assumes that we want it in model orientation, and normally we would if we had put the SVG on the XY plane back at the beginning. If we zoom in on the X, Y, and Z arrows, it shows that Z is not pointing up toward the router, which is a problem, but easily fixed. Switch it from model orientation to select Z-axis plane and X-axis. Next, we need to choose the Z-axis by selecting any vertical line or any plane that faces directly up. So you can simply click right in the middle of Yoshi's nose, or on any of the little up and down lines around the edges. Click on his face, and you see the Z arrow points up now. Click the X to clear the Z axis, and try any vertical line. Now the axis is still correct, but the arrow is pointing down. Check the little box for flip Z axis, and it's going the right way again. Next, we can choose the X axis. However, if all three arrows are pointing the right way, we can just skip it. If you really want to, you can click the red X-axis line. Also, you can flip the X-axis if the arrow is pointing the wrong way. The next options are for the origin point, but we need to go define the stock first. Switch to the Stock tab at the top of the window. In Fusion, stock is what they call the board that you will put on the CNC. Back in design mode, we told it how it should look at the end. Defining the stock is telling it where it needs to start. While there are a bunch of options on the list to define the stock, we're going to leave it on relative sized box today. We're also going to leave the next option set to add stock to sides and top bottom. For the side offset, it doesn't really need to know the exact size of the board. However, it does need to know if a tool path around the outside of the model is running through air or wood. To prevent problems, add a minimum of at least the width of the bit. As we'll be doing most of this with a 1/4 inch end mill, we should add at least 0.3 to the sides. Let's just add 0.5 inches to be safe. Now, the top offset is easy. How thick is our panel? I would make this project by gluing up a panel with cheap 1x4 or 1x6 boards, which are 3/4 of an inch thick. Our model is 0.6 inches, so with minimal math used, we need to add 0.15 inch stock to the top. Did we do the math right? Down at the bottom, it shows the dimensions of our stock panel. The X and Y are the minimum size we need to make our panel glue up, and the Z should equal the 0.75 inch thickness of the boards. Now, we need to go back to the Setup tab. We need to choose the origin point, the X, Y, and Z zeros. You can pick any point on the stock, any point on the model, or any point anywhere you want if you're crazy enough. We're going to pick a stock box point because the corner of the panel is easy to find, and I've always had a preference for the lower left-hand corner. The big choice here is to zero from the top or bottom of that corner. My advice, if you are only planning on cutting pockets from the top, then zero from the top. However, if you're going to cut out the project down to the spoil board, zero from the bottom, and your spoil board will thank you. Also, if you will need to switch bits while machining the model, you need to consider that the top surface may not exist to zero off of after the initial tool paths, in which case the bottom zero is a necessity. Today, we're going to choose the bottom point in the lower left corner as 0. We don't need to touch the accessibility analysis or the post-process tab, so let's just click OK to create the setup. We did it! We made a setup! Now, we're finally ready to play with toolpaths. There are tons of different paths available under the 2D and the 3D drop-downs, but we're just going to use a few to carve Yoshi. Because our panel is 0.75 inches thick and the project is only 0.6 inches thick, the first thing we need to do is surface the top of the panel down to the correct height. To do that, click 2D and choose a face toolpath. Now, at first glance, this window has so many tabs full of confusing numbers and checkboxes, it can be intimidating. We're going to set a few specific fields and then assume that any field that we don't understand is probably best off just leaving the Fusion default. The first thing we need to do is choose the tool. So click the Select button at the top. Welcome to the tool library. If you plan on using Fusion often, you should really put the effort into adding all the bits you own to your local library. For today, we're going to cheat and use samples from the Fusion library. Click on Milling Tools, Inch. To narrow that selection down, click the checkbox over on the far right for flat end mills. We're going to start with the workhorse of the hobby CNC, the 1/4 inch end mill. However, if you have one, using a 1-inch surfacing bit would make this path much faster. Click the 1/4 inch flat end mill and ignore all the confusing numbers that just popped up at the bottom. Just click Select in the bottom corner and trust the defaults. You can disable the coolant flood if you like, but a hobby CNC doesn't have coolant and it will just ignore that G-code if you leave it on. The only number we need to change on this tab is the cutting feed rate. What's a good feed rate? Well, Carbide Motion and similar CNC control software lets you adjust the feed rate while it's running, anywhere from 10% to 200%. I just start with 100 inch per minute and know that that will give me a working range between 10 and 200 inch per minute, and I can easily find the sweet spot while it's running. Next is the Geometry tab. It defaults to the outline of the stock, which is fine. If you want to speed up this path, you can select the outline of the body and it will only machine in that area. I usually won't bother unless it'll make a big time difference. The next tab is Heights. If you rotate the model to look at the front edge, you can see each height visually. The top 3 are usually fine with default values, but we need to check the top and bottom heights. A face path, by default, will clear everything from the top of the stock down to the top of the model, because that's exactly what we want it to do. We're not going to need to change anything here this time. The next tab is Passes. Here we can set the pass direction. The default of 0 degrees will generate a clearing path that goes left and right. If the grain on the wood goes the other direction and you want the path to clear up and down, then just change it to 90 degrees. The next important one is step over. Anything around 0.175 is usually fine. Setting the direction to both ways means it cuts when going left and right, which saves some travel time. The next important box is for multiple depths. Without this option, it will cut the entire depth in one go. I'm going to set the maximum step down at 0.06 inches. Let's click OK and watch it generate the toolpath. You can see the toolpath goes back and forth, and if we zoom in, we can see that it needs 3 passes at 0.06 to remove the 0.15 inch of material. If you right-click the path and choose machining time, it estimates 1 hour and 41 minutes. You can double-click the path to jump back in and edit anything. Let's adjust the step down to 0.08 and click OK. At that depth, it only takes 2 passes to surface it down. That should save us some time. Yep, we just saved a half hour there. The solid green area is showing you exactly what material is left of the stock after the path. If you turn on the path's visibility and click away, it will show you the path and the body instead. Next, we're going to carve out these pockets. Click 2D and choose 2D pocket. Tool selector will assume that we're going to use the same bit as the last path. As we're going to use the 1/4 inch end mill to remove most of the material from the pockets, we can leave it. The feed rate will also be what we chose for the last path. On the Geometry tab, we need to define which areas to pocket. You can click on the bottom edge of a pocket vector, but it's much easier to click on the bottom face. Click in each pocket to select them all. Just click, no need to hold Control for multiple selections. If you click the wrong surface, just click it again and trash it. The next tab is Heights. We don't want it to carve from the top of the stock, just from the top of the model down to the bottom of the pocket. In theory, leaving the bottom height on the selected contours should do what we want, but I have trust issues. Just to be certain, I'm going to change it to model top minus 0.3 inches. Over to passes. It's chosen 0.15 as the step over, which should be fine. We don't need it to leave stock behind, but we do want multiple depths. I'll be conservative with a 0.06 roughing step down. If you want it to be extra gentle at the bottom, you can have it do a couple shallow passes by adding some finishing step downs. Let's click OK and see what it does. It looks pretty good, but we're definitely missing some of the smaller details. My advice is to minimize the number of tool changes, so we're going to carve the outline before fixing the details. Click 2D and choose 2D contour. Tool and feed rate are still fine. For the contour selection, click the outer edge vector. It usually guesses right, but you can click the arrow to switch from cut outside the line to cut inside the line if you need it to. This is where you can add tabs if you want to. You may have heard that Fusion doesn't support tabs, but that only applies to 3D toolpaths. Here you can set the shape, width, and height of the tabs. It can position them every few inches, or you can just tell it that you want a couple down here and another up here. We need the heights to carve from the model top down to the model bottom. We just need to set the multiple depths and the step down back to 0.08 again. That should do it. Let's click OK. Looks good. You can see it left the tabs untouched. A close look at the path shows it jump over that spot. Okay, so about these missing details. If we want to, we can create a new pocket toolpath and select all those pockets again. But we've already done that, so let's take a shortcut. I'm going to right-click on our pocket toolpath and choose Copy. I'm going to right-click on our Setup and choose Paste. Now is a good time to mention that you can click once on a selected toolpath to edit the name. I find that adding the tool I'm using in each path to the names helps prevent mistakes later. Double-click to edit the path. We need to go select a smaller tool. Back in the milling tools, we're ready to select the 1/8 inch flat end mill. If you happen to own one, you could choose a 1/16 inch end mill instead to get even finer details. The feed rate dropped automatically, so that looks okay. The pockets are already picked, but since we don't want to spend all day recarving the entire pockets, we're going to check rest machining, and it will only carve what it couldn't reach last time. The tool diameter set here is the size of the last tool that carved these pockets. Because the last pocket path used a 1/4 inch end mill, we'll make sure this is set to 0.25. It's already adjusted to a sensible step over, and we should still be okay with this step down. Okay, what do we get? Not much. It's hitting all the tight inside corners and the few areas the bigger bit missed. That's going to save us tons of runtime. And since we're perfectionists here, let's do the same thing with the contour path. Copy the path and paste. Rename it quick and double click to edit. Change the bit to 1/8 inch again. We don't need to redo the tabs, and use rest machining with a 0.25 as the previous tool. It only needed to hit a few tight inside corners, but hey, why not? Now that we've used rest machining, you can see that the order of the tool paths can be very important. If you need to move a path up the list, just grab it and drag. All right, we've got all the paths ready. Let's get them out of Fusion. We can't combine paths with different tools unless you have a tool changer and the paid version of Fusion, but we can combine all the 1/4 inch paths into one file. Click on the face path, hold Control, and click the 1/4 inch pocket and the 1/4 inch contour. Right click and choose Post Process. Okay, this step I can't do for you because it's specific to the code that your CNC controller understands. I have a Shapeoko, and I had to download a config file from Carbide 3D for this, but according to their site, Fusion has it built in now. I'm going to choose Carbide 3D from the list. If you don't see your machine, you may have to check their website for info. I'm going to pick a sensible file name and set the output folder. Last, click Post. Let's do the same with the last two. Click the 1/8 inch pocket, hold Control, and click the 1/8 inch contour. Right-click and post-process. It remembers the machine code and the folder, so let's pick a file name and post. Okay, let's make Yoshi. I'm going to go back into the setup because I forgot how big the stock needs to be. Around 14 1/4 wide and 15 3/4 tall. Glue it up, screw it down. Push the easy button and watch the robot do all the work. If you do make a Yoshi, please tag me on Instagram. I would love to see it. If your Fusion Cam video is better than mine, feel free to tell me everything I did wrong. I'm sorry if I went too fast, but I will happily apologize to you again if you rewatch the video. Switching to the 1/8 inch passes. This rest machining sure saves a bunch of time. What has it got in its pockets? Ew, dinosaur boogers. Gotta reach those tight spots around the edges. And done. I normally work with hardwoods to avoid using paint. I think you can see why. Thanks for watching. Please like and subscribe and comment and follow me on Instagram and support me on Patreon and check out these other videos where I use Fusion Cam to carve Groot from 5 sides and make an insane lampshade. Catch you next time.